Hello everyone, welcome to my channel. Today I will discuss about chapter 3 worksheet 2. Now we solve question number 1. Express the following rational numbers as decimals by using long division method. 21 by 16. First we divide 21 by 16. Here we write 21, then you put 16. 16 1 is 16. Then 21 minus 16 is 5. Then 5 is less than 16, so here you put decimal and using 10, 50. Then 16 3 is 48. Then 50 minus 48 is 2, 2 is less than 16, then here you put also 10, 20. Then 16 1 is 16. Now we find 4, then here put also 10, 40. Then 16 2 is 32. Then 40 minus 32 is 8. Then here is also 10. Then 16 5 is 80. 80 minus 80 is 0. So hence 21 by 16 is 1.3125. Here we find remainder is 0, so it is a terminating decimal. Terminating decimal. Now we solve another point. 129 by 25. Now we divide it. First write 25 5 is 125. Now we subtract it. 9 minus 4, 5 is 4. 25 4 is less than 25, so here we put 10 decimal and put 10. Then 25 1 is 25. Then 40 minus 25 is 15. 0 minus 5, you cannot subtract it, put 10, then 15. 15 is also less than 25, then you put here is also 10, 150. Then 25 6 is 150. Then 150 minus 150 is 0. Here we find remainder is 0, so it is also terminating decimal. Now we solve another point. 17 by 200. Now we divide it. 17 is less than 200. Then here we put point and use 10. Then here 170 is also less than 200. So here we put 10 and here we put 10. Then 1700. Then 208 is 1600. Now we subtract it. 0 0 7 minus 6 1. Then 100 is less than 200. Here put 10. Then 200 5 is 1000. 1000 minus 1000 is 0. So here remainder is 0. So it is terminating decimal number. Now we solve another point 4. 5 by 11. 5 is less than 11, so here we put decimal and use 10. 50. 11 4 is 44. Then 50 minus 44 is 6. Then here we put 10, 60. Then 11 5 is 55. Then 5, here we put also 10, 50. Then 11 4 is 44. Then we find 6 and put 10, 60. Then 11 5 is 55. Then 60 minus 55 is 5. Here is repeating. So it is a non-terminating repeating decimal number. So write It is non-terminating repeating decimal. Now we solve another point. 22 by 7. Now we divide it. 7 3 is 21. Then 22 minus 21 is 1. Then 1 is less than 7, so use here decimal and put 10. Then 7 1 is 7. 10 minus 7 is 3. Here you put also 10. Then 7 4 is 28. 30 minus 28 is 2. Then here is also 10. Then 7 2 is 14. Then 20 minus 14 is 6. Then we put 10. Then 7 8 is 56. Then we find 4. It is non-terminating decimal number. The remainder is 4, so it is non-terminating decimal number. Now we solve another point. 31 by 27. Twenty-seven 1 is 27. Now we subtract it. 31 minus 27 is 4. Then 4 is less than 27, so we put decimal and here use 10. Then 27 1 is also 27. Then 40 minus 27 is 0 minus 7. We cannot subtract and borrow. 10 minus 7 is 3. 3 minus 2 is 1. 13. Then 13 is less than 27. Then you put 10. 113. Then 27 4 is 108. 0 minus 8 we cannot subtract and borrow. 10 minus 2 equal to 10 minus 8 equal to then 2. 22. Then here we put 10. 220. Then 27 8 is 216. Then 20 minus 216 is 4. Here we put also 10 and 40. Then 27 1 is 27. Now we find 13. It is also repeated. Non-terminating and repeated. So we write non-terminating repeating decimal. Non-terminating repeating decimal. Now next point 2 by 15. So divide 2 by 15. 2 is less than 15, so you put decimal point and here put 10. Then 15 1 is 15. Then 20 minus 15 is 5 and here put 10 50. Then 15 3 is 45. And 50 minus 45 is 5 and here put 10. Then 15 3 is 45. It's also 5. Then you put 10. 15 3 is 45. Then you also 5. Remainder is 5. So we write non-terminating repeating decimal. Non-terminating repeating decimal. Now we solve another point. 63 by 55. Now we divide it. First 55 1 is 55. Then 3 minus 5 we cannot subtract it, 1 borrow. Then 13 minus 5 is 8. Then 5 5 0. Then 8 is less than 55, so here we put decimal and put 10. Then 55 1 is also 55. Then 80 minus 55 with 0 minus 5 we cannot subtract it, 1 borrow. 10 minus 5 5. Then 7 minus 5 is 2. 25. 25 is also less than 55, so we put 10. 250. Right, 55 4 ja 220. Then 0 minus 0, 5 minus 2, 3. Then 30 is less than 55, then we put 10, 300. Now write 55 5 ja 275. 0 minus 5 we cannot subtract and borrow, then 10 minus 5 5, then 9 minus 7 2, then 2 minus 2 0. 25 and put 10. 250, then 55 4 ja 220. Then we find 30. It is remainder is 30. It is terminating repeating decimal number. So we write non-terminating repeating decimal. Now solve with question number 2. Without actual division, determine which of the following rational numbers have a terminating decimal representation and which have a non-terminating decimal representation. First I 11 by 4. First I find prime factor of 4. Prime factors of 4. Prime factor of 4 is, wait, for 2 2 is 4, then 2 1 is 2. Prime factor of 4 is 2 into 2. Here the denominator 4 has prime factor is 2 to the power 2. So 11 by 4 is a represent terminating decimal number. So we write here the denominator 4 has prime factors to the power 2. So 11 by 4 represent a terminating decimal number. Terminating decimal number. Terminating decimal numbers. Now we solve another point 2. 13 by 80. First I find prime factors of 80. 40, then 20, then 2 10 ja, then 2 5 ja 10, then 5 1 ja 5. Now write prime factors of 80. Of 80 equal 2 into 2 into 2 into 2 into 5. Here 2 to the power 4 into 5 to the power 1. Hence 13 by 80 represent terminating decimal number. A terminating decimal number. Now we solve another point 3. 15 by 11. Here the denominator 11 has no prime factors. So we write here the denominator (11) has no prime factors. As 2 to the power m into 5 to the power m. Hence 15 by 11 represent non-terminating decimal number. So we write 15 by 11 is represent non-terminating decimal number. Then now we solve another point. 4. 22 by 7. Here denominator 7 has also no prime factor. So it is also non-terminating decimal number. We write the denominator 7 has no prime factors. As 2 to the power m into 5 to the power n. Hence, 22 by 7 represent non-terminating decimal number. Non-terminating decimal numbers. Then another point, V 29 by 250. First, we find prime factor of 250. 2 1 is 2, 2 2 is 4, 2 5 is 10. Then 5 2 is 10, 5 5 is 25, 5 5 is 25, 5 1 is 5. We write prime factors of 250 equal 2 into 5 into 5 into 5 equal 2 to the power 1 into 5 to the power 3. Hence, prime factor of 250 is a terminating decimal number. Here, the prime factors of 250 has 2 and 5. 2 and 5 only. So it represents terminating decimal number. Now sir, another point, VI 37 by 21. Here prime factors of 21 is 3 into 7, 3 7 is 21. The denominator has no prime factors to the power m into 5 to the power n, so it is non-terminating decimal number. So write it is non-terminating decimal number. The next point, VII 49 by 14. Then first I write prime factors of 14 is 2 into 7. Prime factors of denominator are in the form 2 to the power 1 into 7 to the power 1. So it represents terminating decimal number. Write prime factors of denominator are in the form to the power 1 into 7 to the power 1. So it represent terminating decimal number. Now we solve another point V triple I. 126 by 45. First we find prime factor of 45. 5 9 is 45, 3 3 is 9. So prime factor of denominators denominators 45 are in the form 2 to the power 0 into 5 to the power 1 is 45 equal 5 into 3 into 3 equal 5 to the power 1 into 3 to the power 2. So it is represent terminating decimal number. So it represents terminating decimal number. Now we solve question number 3. Find the decimal representation of the following rational number. First write minus 27 by 4. First we write minus 27 by 4. Here we multiply 10 is less than 4, so here multiplied 25 because we find 100. 25 for the 100, here we multiply 25. Then 27 in 25 is minus 675. Here is 2 0, so we left right hand side is 2 number. Minus 6.75. Then now we solve another point 2. Minus 37 by 16. Here prime factor of 60 is 2 3 is 6, then 2 15, then 3 5 is then 5. Prime factor of 60 is 2 into 2 into 3 into 5. Here not in the form of 2 to the power m into 5 to the power n. So it is non-terminating decimal number. It is non-terminating decimal number. So you will use long division method. In 37 is less than 60, so you use your decimal and put 10. Then 66 is 360. Then 0 minus 0 7 6 is 1. Then 10 is less than 60. 7 minus 6 equal 1. Then 10. Here we put 10. Then 61 is 60. Then 100 minus 60 is 40, and here put is 10. Then 400. Then 66 is 360, and we find is also 40. Then put 40. Then 66 is 360. Here we also find 40, and remainder is 40. So it is a non-terminating repeating decimal. Minus 37 by 60 equal minus 0.616. It is non-terminating repeating decimal. Now we solve another point 3. Minus 18 by 125. First we find prime factors of 125. 5 2 is 10, then 5 5 is 25, 5 5 is 25, 5 1 is 5. So write 125 equal, prime factors of 125 equal 5 into 5 into 5 equal 5 plus 2 into 2 to the power 0. So it is terminating decimal number. We write minus 18 by 125. Then you multiplied 1000 is 8. 125 8 is 18, 8 is 144. So here is 30, so we left right hand side is 3 number and minus 0.144. Another point is minus 15 by 8. First we find prime factors of 8. 2 4 is 8, 2 2 is 4, 2 1 is 2. Right, prime factors of 8 equal 2 into 2 into 2. Then 2 to the power 3 into 5 to the power 0. So it is a terminating decimal number. We write minus 15 by 8. Here we multiply 10 is less than 8. 100 is cannot divided by 8, so 1000. So here we multiplied 125, 8 is 1000. Then 125 into 15 is 1875. Then you put minus sign. Then here is 30. So we left right hand side is 3 number. Minus 1875. 1, 2, 3. Here we put decimal. Minus 1.875. Now we solve another number. If the number 1 by 2 plus 2 by 3 plus 3 by 4 plus 4 by 5 is expressed as a decimal, will it be terminating or non-terminating? Justify your answer. First we see the denominators are 2, 3, 4, 5. They are not all in the form of 2 to the power m into 5 to the power n. So it is non-terminating decimal number. First I write the denominators. The denominators are 2, 3, 4 and 5. 2, 3, 4, 5. They are not all in the form of two to the power m into 5 to the power n. So therefore the given numbers is a non-terminating decimal representation. Decimal representation. Now we solve question number 5. Justify the following statements as true or false. 22 by 7 can be represented as terminating decimal number. It is false because 22 by 7. Here prime factors 7 are not in the form of 2 to the power m into 5 to the power m. So it is non-terminating decimal number. So we write it is false. Then another point, 51 by 512 can be represented as a terminating decimal. First we find 512 prime factors. 2 2 is 4, then 1, 2 5 is 10, 2 6 is 12, 2 1 is 2, 2 2 is 4, 2 8 is 16, 2 6 is 12, 4 is 8, 2 3 is 2 2 is 4, 2 1 is 2, 2 6 is 12, 2 8 is 16, 2 4 is 8, 2 2 is 4, 2 1 is 2. 1 2 3 4 5 6 7 8 9. 2 to the power 9 into 5 to the power 0. Hence it is terminating decimal representation. So it is true. Now we solve another point. 19 by 45 can be represented as non-terminating repeating decimal. First I find prime factors of 45. 5 9 is 45, 3 3 is 9, 3 1 is 3. 5 into 3 to the power 2. First I see here prime factor of 45 is 3 into 5 and not in the form 2 to the power m into 5 to the power n because it is 3. So it cannot be represented as terminating decimal number, so it is true. Then another point 4. 3 by 17 cannot be represented as terminating repeating decimal number. It is true. Because 3 by 17 your prime factor 17 are not in the form of 2 to the power m into 5 to the power n. So it is a non-terminating decimal representation. Answer is true. Then another, if 3 by 2 and 7 by 5 are terminating decimal, then 3 by 2 plus 7 by 5 is also decimal number, decimal terminating. First we see it is true because here denominator are 2 and 5. 3 by 2 plus 7 by 5 is also a terminating decimal number. So we write it is true. Then another point, if 1 by 4 and 1 by 5 both have terminating decimal representation, then 1 by 4 into 1 by 5 has also a terminating decimal representation. It is also true. Here denominator are 4 into 5 in the form 2 to the power m into 5 to the power n because 4 is 2 to the power 2. So it is a terminating decimal representation. So we write it is also true. Thank you.